Hello everyone, I'm back with a new test. I'm going to increase even more the surface area, the area of the cell. So what I did, I took the active material from cell 1, which was the thicker one, and the surface, the area on this one was 150 square millimeters. Remember, was 10 by 15 millimeters. So 150 square millimeters. In the second cell, I had 10 by 30, so was the double of the area from cell 1, but also was half of the thickness. And what I did now, I have the active material from cell 1 placed in another cell, and the surface area, the area of this cell is 600 square millimeters, so is double the second one and four times the first one. Just place the active material now on the graphite, a normal filter paper, like I did in the first test, and a piece of zinc as a current collector on the anode. I've just plugged it, and already you can see, without charging it or nothing, it was on 1.62. It is decreasing slowly, but still was a very good voltage for a cell that was just made. I'm going to leave it for a few hours to make sure that the electrolyte is soaked very well into the active material, and then I'm going to run a few discharging cycles, and we'll see if increasing even more the area of the cell will help us, will give us better results or not. As another point of discussion, if you remember, on the second cell I did a video with a new separator electrolyte, and this is the one, the thick one. The PVA from the recipe dried out almost completely, is now very brittle, cracks. Yeah, this is the one that I've used, and I had pretty good results. Now, as you can see, I'm using much thinner one. I'm going to try to show you on a different. I don't know if I can make this phone focus well enough. Is a much thinner one, is a 0.14 of a millimeter, when the other one was 0.6 of a millimeter, so is 4 times thinner. But I have to make a confession, it's rubbish. That great performance, it totally disappeared. As I tested here on cell 2, now it is barely able to run at 10 milliamps for, I don't know, between 5 and 10 minutes. Is that bad. So I'll have to keep looking more into this recipe to improve it more, because there are many to improve in this recipe. But till then, we are back at cell 3, let's call it, with 4 times the area of the first one. The same active material. Dropped a little bit more, but we will see in a few hours where it will stabilize and what we are going to achieve with this increased surface area. Thank you everyone. See you later. 2 hours later, I've charged this cell for 5-6 minutes. I've added some reinforcement just so I can make sure that I have a good contact in all 4 corners. It's now discharging. Doesn't look that great, but as I said, this is the first discharge. And I think if I would change again the cutoff voltage to 0.2, the time will increase significantly. As you can see, in the first part was a good decrease of the voltage, and then suddenly started to increase each step, and now in the last part again is discharging with roughly 3 millivolts per second, or maybe even less. And yeah, I'll be back. First discharge has finished, 6 minutes and 22, but the cutoff voltage was at 0.5. I'm going to charge it again, this time just 5 minutes, but I'm going to change the cutoff voltage to 0.2 just so we can see something similar, or we can compare with the initial test that we did with this material when it was on a thicker layer and 4 times less the area, the contact area. See you in a bit. Again, the voltage is increasing. Is now the current draw is increasing. It dropped to 21 and now is on 26. I'm going to stop it now because I don't want to destroy this cell yet, and I'll discharge it. The initial voltage drop wasn't that high. I think it was just 50 millivolts from maybe 100 millivolts, from 1.9 to 1.8. Discharging nicely till now. I'll be back towards the end. Second discharge with the cutoff at 0.2 volts is showing us one clear thing. The energy density is more in the area of, let's say, 0.5 to 0.2 of a volt, and this is an issue that I will have to address to shift this energy density from this area to that area where I want more. And I'll have to see how I'm going to do that. I have no idea for the moment. Anyway, was a good run, 43 minutes. Especially that it had a very short charging cycle. I think maximum 2 minutes, due to that increase in current draw. I'm going to charge it again, run a few more discharges, and then we'll see. Third discharge looks very disappointing, and I don't know exactly what happened now. I'm going to keep charge and discharge this one. See you at the end of the next discharge. Now this is the second day of testing cell 3. I had a few bad results yesterday. After that good result, the next ones were not longer than 5 minutes, so pretty bad. I had issues with charging the cell. The current draw was dropping down, then increasing a lot, and I was stopping it pretty quickly after I was starting the charging sequence. But the latest result is a little bit better, 14.43. I don't want to make this video longer than it is already. I think, disregarding the charging issues with this cell, we can say that by increasing even more the contact area between the two electrodes, the results are getting better, even if we have the same amount of material and the layer is actually thinner. The layer of active material is thinner. For sure, going from 150 squared millimeters, a thick layer, to this one that has 300 squared millimeters, and then moving to this one, the results were better. Now I'm going to work on fixing I think it's the electrolyte, an issue with the electrolyte, I'm not very sure, but I need to fix this charging issue. I think I might know exactly how, and then I'm going to carry on making more tests. Thank you so much for watching this video, and I'll keep you updated. Never stop learning.